There's no sound.
There we go. Thank you. Thank God you're watching. One bit. Welcome back again. My God, I've just been yattering away to myself there and got absolutely nowhere.
Okay.
So, so I was just saying that we need to. We're going to do some character movement today, and we want to move our character from one location to the next. If our player is in location 1 here, and a character leaves it, an NPC, then we want exit audio or noise of the player leaving. If the player is in location 2 and a character arrives, we want the sound of that character arriving. Then we want some sort of schedule for the character, so times at which they move. So we've already got this use exit method. So if we can map that to allow our characters to use it, then the characters should trigger the same audio that we need. And then we need some kind of location behavior. And what are they doing at the locations? What a great start. I was just thinking to myself, you know what? I should really make sure I don't forget to turn on the sound. And then I need some sort of alert. But thanks, One Bit. How are you doing today? Are you working on your project? And how much time are you getting to work on your project? Let's fire up Godot. All right, so we have got our character scripts. Here they are. They're wonderful detail. Actually, I think we did away with the need for this node extraction. So our characters currently have current location, a previous location, a face, color for their text, a voice pitch, an interaction script if we interact with that character, the talk function, which starts our third-party system for dialogue, the interaction script, and that's about it at the moment. So it's nice that we can just literally talk to a character wherever they go. Let's just test Graham, make sure he's working okay. Where are you, Graham? You are in the balcony, I believe. There we are. That's Graham. Yep, cool. What would be nice is if that was actually a verb to interact with the character. So one thing we haven't got at the moment is any sort of interaction verbs for our characters, which we probably should have. We've still got to get to the inventory system. That's going to be fun. I hope you're around when we do that, One Bit Godot, because I think you've already got some experience in that, right? I'll probably watch a few videos on it first, just get an idea of how people have approached it, and look at how we want to do it. It's going to be a bit odd because the way we're creating functions here, our sort of verb system doesn't lend itself to like...
Actually, I wanted to live stream earlier today, but I had a health issue since morning and I'm still not well enough, so I'll try to push it tomorrow.
Oh, well, look, I'm sorry to hear that. I hope you're going to feel better tomorrow. But if you're going to do that, then absolutely let me know when you're going to stream. I'd love to catch it. And if you want me to, if you know what time you're going to do it, then I will advertise it on my stream as well. Why don't we create a little Godot live streaming network? That'd be good. I think, you know what, I'd watch this sort of content. There's another one I watched called, I think it's Deranged Games. But it's on really late. It starts at like 4 in the morning or something for me. I think that's what it's called. Deranged Games. Nope. Clearly it's not called that. Oh, Deranged Turtle Games. So I think it's the only other one I've really seen doing Godot live streaming on YouTube. I mean, there's a few of them, but no one really doing it consistently. But he is doing it pretty much 3 times a week. So, but yeah, please let us know when you're going to do that. I'd love to tune in. So, and plus, of course, we can do a little bit of advertising on the Twitch as well if you want.
Probably 2 or 3 hours before your stream is perfect time for me.
2 or 3 hours. So that would be, where are you based? That'd be like 6 p.m. for me, which would be pretty good for me as well to watch. Right, let's see now. Yeah, we've got no verbs associated with our characters. You know what I love about the live streaming one bit is it adds structure to your daily coding. So there's an accountability to it. Even if no one watches your stream, it sets a schedule for you. So you're going to code and you're going to live stream. You're setting aside that time of your day. It really helps. Plus, I like the accountability side of it. I want to actually finish this because I'm creating this something that's going to sit on YouTube, which I can look back on and go, oh yeah, I did that, rather than that game that just sits away on a floppy disk that you did in the 1980s that you never see anymore and you can't play because well, you could emulate it, I suppose. I've got a few of those. Right. So I'm gonna add some verbs to the character script, and I think there's always going to be
I'm in Asia, so it will after midnight. It's only time that is quiet enough to stream. It's 4:00 am here now.
Oh, wow. Bloomin' heck. Jeez, why are you up so late? Is that the work you're doing? What do you do? I feel guilty that you're watching me at 4 a.m. Okay, so our character now has some verbs associated with it, which is just an array. So we're just going to set our first one to talk. Just doing the same thing that we did with the object. So let's look at our object GUI output, which will be in player. Use exit. Nope, it's not in player. Where will it be? Game. Yes, it's going to be in game, and it's going to be display characters. Okay, so we're basing this. So I'm just going to close all the other tabs. We're basing this on object. And we've created some helper functions for object, like add verb and remove verb and change verb. I don't think we're ever going to really need to do much of that with a character, but maybe you might want to rescue a character. You might want to wake a character. I don't know, there could be all sorts of reasons for doing that sort of thing. So if I was to write this again, I'd certainly use inheritance a little more. It's a little bit haphazard. So that's not where we're spitting out our information here. Display objects is where we do. So for verb in object verbs, add new buttons. And we've got an on item press, so we're going to want to do something similar for our character. We have got an on button, character button up. So essentially, our object is a pop-up, and our character is just a button. So it looks like we based our buttons for our character on exits and not objects. It's a bit of a shame. I definitely want to change that now. I also want to get the characters moving around, so I'm going to put that on my list to do. And let's focus on what we're here to do. Try not to get distracted by the many things that we need to do. So objects, exits, locations, triggers, characters. So we want to add character verbs as per object pop-up menu. Super. So we'll get onto that. Let's get characters moving around first. So what I wrote down on that little list is that we'd have a time, and then use an exit and time. We'd create a schedule for our character. But that could be a ridiculously complicated schedule, right? So I think what we need is we need some kind of behavior loop. I don't want to make it too scripted. But also, I've never done any sort of behavior tree stuff before, so I'm a bit intimidated by that sort of thing. Let's have a look. Behavior trees. Godot. Godot behavior trees. Well, it's time to learn this stuff, I think. Oh, thank you very much. Water. Perfect for when you've got to do a live stream. The behavior tree is a popular way to code AI, right? Which is kind of what we want to do. In a game such as how the NPC non-player controlled characters act. In this tutorial, we'll try to create classes in Godot that allow us to implement a Godot behavior tree. Oh wow, we've randomly found a tutorial. Wonder if it's 3.2 happy. The traversal of the tree happens on every tick of the game, so in Godot it would be on every video frame. That's fine. We will base our code implementation on this behavior trees article. Let's have a look. Cooey. Okay. Yep, so basically it's this sort of thing. What shall I do? How shall I do it? The root task is decomposed into two child tasks, the left child being a condition that an enemy is visible, and the right child being an action which makes the NPC run away. What I'd normally want to do with this sort of thing is I'd rather go through this and work out how to do it myself. But I just know that whatever I'd create would be substandard. And you know what? The wheel's been made here. Hopefully it's decent. So our behavior tree will have an entry point to start it off, first node, and it will poll the status of its child's node on every frame of the game. The children will obediently report status back when asked. An actual behavior is comprised of a sequence of decision-making based on external circumstances. Translated in a programmer speak, there is an object in a context, and it can traverse state-based on various routes around a tree structure. So we've got points on our tree, and our behaviors like moving along the tree to different behaviors based on external influences. So there's where are we now, and what external influences are there to consider? State and context. I mean, I don't even know if we're going to need to go this complicated. At the moment, we're looking at very sort of static stuff. We've even got conversations between given NPCs in a given location. We've also talked about having an NPC being two people, so that they're always in the same place at the same time. We've heard in one of the old episodes, a recording of two people having a conversation. So, I mean, okay, yeah. So we could have working, going to sleep, sleeping. So, returning to if they want to go to sleep, they've got to return to their cabins. They've got to navigate to their cabin. I don't know if this is a good idea. This opens up a bit of a can of worms for us. We're going to have to teach our AIs what's where and how they traverse. So we're going to have some sort of pathfinding as well. What I don't want to do is make it too simplistic and then go, you know what, I should have done this. Above code comments were mentioning abstraction files. So we've just written the whole thing. Start with a base class that every node in the behavior tree will inherit from. This task class will provide all the essential functionality for the leaf and branch nodes that may be extended upon or adopted as need be. I think we've got to go down this road. I want to go down this road. I want to learn this stuff. So basically we're saying, here's a behavior. Here are the states of each behavior, presumably. Not sure what guard or tree or control is for. Final methods running. So right, so basically this is a node in our tree. It is a leaf on our tree. So this is how the state when you reach that leaf would be. So you could be running that method, which could be attacking or defending or whatever, running away. Whether or not it completed on it, or failed, or got cancelled for some reason. Process the task. Non-final, non-abstract methods. Start. Reset. It's basically starting from the beginning. In the above code, comments we are mentioning abstract and final. This is borrowed terminology from the Java coding world, which means final, don't change it, and abstract, put your own spin on it. Okay. Super duper. The leaf node. The leaf node. Oh, okay, so that wasn't the leaf. I thought that was a leaf. That's the task. This is the leaf. The leaf node is the action object. It does stuff according to its current state. Each leaf node will extend the task class and call running success or fail. Its run method will be called on every tick. A state machine may be a good fit for its run code structure, unless it's doing something trivial. Here is code for a most basic leaf node that simply reports success. Fabulous. Okay, for testing, we'll create various leaf nodes, such as this counter. Okay. This does its work in the run function, reports a running status until the count has reached 100 when it reports success. So it runs, and while it's running, it increments count. If the count is less than max, it keeps counting. Otherwise, it's done. Cool. Topmost node of the behavior tree is referenced by the tree property and may have custom methods we may call, such as show value in this example. Decorator nodes. A decorator wraps its child class, modifying or selectively ignoring the child's status reports. So we will initially implement these decorators. Always fail, always succeed. Invert, that means do it backwards. Limit, repeat, until fail, until success. Cool. Okay, that makes sense. So yeah, we might want to change the way we run a class. So little unsure. Okay. A child node is optional for this node, but if it exists, we call its run method. Example code for invert. Yeah, so this is what I did wonder. So class name invert. So functions run, it gets the child, 0, sets it to running. It must have a child node that provides updates. Code for repeat. Repeats the child task and reports success after repeating, unless it fails. Oops. Ugh, where were we? So extends task. Class name is repeat. Oh, look at that. I thought we couldn't do that. That's what I wanted to do. Wow. I didn't know I could do that. I've got to try that. I'm just going to pop a little note in there. Wonder how that works. Let me just try that real quick. So let's go for location, class name, location, and our icon can be icon.png. What's that even do? If I quit and load the project again. Oh, brilliant. So look down over here, you can see now we've changed the icon for locations. So we can actually make our tree much more visual, and presumably being able to actually identify a class by class name. See, I've been using this instance name thing here just to kind of
If you drag a file into the script, Godot will copy the path for you. No need to copy and paste the file path.
Nice, good hint. Thank you very much. Excellent tip. So, yep, one bit saying that we can just drag any file in here. So if we want to link from the icon, we could just drag it in, and voila, super duper. So that's pretty cool. So we could actually add, class names to all our classes, which is great. More stuff I need to rewrite. But like I say, this is first time, so, well, kind of second time, but first time doing something like this. Where was I? Yeah, character and... Cool. So number of times to run, or 0 for infinite. So how many times we're going to repeat this task. Then we run it. If not repeating equals true, because we want to turn it to a repeating task, and then run the child and keep running. Keep doing it until we hit a limit, and then repeating equals false, and return success. If it's still repeating, then keep running. If it fails, repeating equals false, and fail. Well, it's hard to see how this is going to work at the end of the day, but I think I have faith. This is I feel like I need to go back and just start coding this out to really get my head around it. I don't want to get his code repository, but I might have to. Let's finish this off. So composite nodes. Composite tasks control how the branches of their children are handled, such as in a sequence or in parallel. Okay, so we will implement these composite tasks: selector, random selector, sequence, random sequence, and parallel. I'm not sure we need our characters to be able to do all this, but maybe to have a working behavior tree, we need to do this sort of thing. So that's this bit here, right? So sequences, just for selector, the non-deterministic variation of the sequence task runs its children in a random order. This comes in handy for certain situations. For instance, suppose you want to burn something. To accomplish this task, you need matches and gasoline, and of course the order you get them in is irrelevant. This can be easily implemented through a random sequence with 2 children. Get matches and get gasoline. I'll tell you what, our AI will be clever if we can get this working on them. Trouble is, well, no, there's no trouble. That's pretty cool. I'm wondering if they can... I'm going to have them interacting with all the same objects the player is. I didn't think they would, to be honest, but they could. Okay, let's carry on. So, code for sequence. So stepping through child sequences, child tasks. Here's the random selector. Here we run the child nodes one by one until one fails or they all succeed. For selector, we do the opposite. We run the child nodes one by one until one passes or they all fail. Code for random selector. So it's index to 0. We define a sequence, things that we need to do, and then we say, I didn't know there was a shuffle function. So we're declaring range. I'm not familiar with range. Is that like a random number generator? Range. Abstract base class for range-based controls. Range is a base class for control nodes. I'm not sure that's correct. Probably another range, right? No, surely not. It's got to be a standard programmatic function there. Looks like it's, shuffle. What's that do? Mix up an array? Yeah. So range has got to return some sort of array. Now I'll come look at that later. Run. Get the child sequence. So we're getting child sequence 0. So we're starting with the first element of the sequence array and running. So if there's 10, who knows what index 0 could be.
Range is a function that returns an iterator for a sequence of values.
Nice. Any link to the manual on that one bit? Couldn't see that there. I'm only getting this range class for control nodes. Is that it? Change a floating point value between a minimum and maximum using step and page. That's not right, is it? Ah. Was that it there?
Search for range.
For range. Is that what I've just found? Yeah, I think that's what I've...
Search on the web.
Oh, okay. For range. Godot. All right. Yeah, I can't find an official doc for range either, but it takes a minimum maximum in steps of X. Right, okay. So 3, 15, steps of 3. So it's going to go 3, 6, and so on. Is that right? depending on what. Yeah, presumably.
Yes,
Okay.
it generates a sequence of values.
Cool. That's very cool. So just putting in a single value will go from 0 to whatever the value is. 2 will give you B to whatever the value is, and 3 will add the step. So in this function, then, we are literally, where is it? I've gone quite past it now, haven't I? Let's just do a search for range. There it is. So we're set up a sequence, and we're stepping through however many. So we're basically saying we're going to step through all these values. Oh, I see. Right. Okay. So if we've got an array of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then this is basically creating an empty array. And then we're shuffling it. So we're just basically shuffling up a sequence. Interesting. I would have thought you'd. I suppose that makes sense. We don't know at this point what we're dealing with, so we get the child count. Blimey! Wow, that's
Getting
cool.
a sequence of indexes based on the number of children, so you can use the indexes to access the children later.
Beautiful. Yep, that makes sense. I have to remember that. Okay, so we're down to parallel. Code for parallel runs all child tasks together in sequence or selector policy mode. Now, let me just remind myself of what that means. A parallel composite task handles concurrent behaviors. It's a special branch task that runs all children when stepped. As we'll see in a moment, the actual behavior of this task depends on its orchestrator and policy. Here are some typical uses of the parallel task. Non-conflicting actions. The parallel task is most obviously used for sets of actions that can occur at the same time. So you can have your character roll into cover while shouting an insult and changing primary weapon. These 3 actions don't conflict. They wouldn't use the same semaphore, for example. Condition checking. One very common use of the parallel task is to continually check whether certain conditions are met while carrying out an action. For instance, you can make your character react on an event while sleeping or wandering. Group behavior. We can use parallel to control the behavior of a group of characters, such as a fire team in a military shooter. Wow. Awesome. Definitely want to learn this. Well, each member of the group gets its own behavior tree for its individual actions. Shooting, taking cover, reloading, animating, and so on. These group actions are contained in parallel tasks with a higher level selector that chooses the group's behavior. If one of the team members can't possibly carry out their role in the strategy, then the parallel will return in failure, and the selector will have to choose another option. That's so cool. Man, this is awesome. Okay. This is pretty heavy duty stuff for my early games programming. So, but we're going to try it. So let's start bringing this into effect. So we're going to create a task class, first of all. Throw this code in there. I just want to start being able to play with it.
This is actually something I will be implemented for my game, but mostly for schedule scripted events like cushions and transitions, not AI.
Interesting. So you could use it as a game, like an overall game controller. That's interesting. So I see. Right. Yeah. I see. I've been thinking about that as well, because I was really struggling with the concept of, when things can happen or should happen. So we've got all sorts of potential for someone talking, someone responding, a cutscene starting, you interacting, and so on. So this could be used to manage the overall game and what things can happen within the game, rather than just controlling a character.
It's basically a task scheduler.
Yeah, totally. Wow, cool. Love it. Okay, well, let's give it a try. So I'm going to create a new script. And this is a task, I believe. The task. So class name task. So we shall call it task.gd. Okay, so I'm just going to kill this stuff here and keep processing there. Right, okay. That. Okay, super. No errors. So I think we only need a couple of these scripts before we can start testing it, right? Yeah, so now we can create the leaf node. Okay. Empty script. Super. Right, now we're ready to give it a try, right? So we can create this counter and let's try this out. But I need to change the way I was actually watching someone else's structure, and I think I got this on some early tutorial that this would be the best way to do it. But it seems more recently people tend to create folder structures for the given objects and group it by the object. So all the assets, fonts, scenes, and so on all grouped together with their script. So we would have some sort of behavior folder and then put all our scripts for behavior in there. It's certainly getting a bit messy in here. I have to have a bit of a rearrangement at some point. Right, what did I just create? Task leaf counter. Where is it? There it is. Super. Right. So sorry about that. Mixed tabs and spaces. All right. Yeah. Happy. That's definitely messed up. All right. Okay, so now I've got to instantiate these in order to test them. Blimey. Okay, so I don't think they give us any example of how we should do this. Entry point. The node at the head of the behavior tree will be an entry point.
If the objects is a base class, I would put the base class in the outer folder and create subfolders for inherited classes. Like if I have a task base class, then counter would be created in a tasks subfolder. Basically using folders to organize scripts based on their category.
Cool. Is that I'm just wondering how that works in terms of Godot loading the scripts. So I'm saying that that counter extends task. I have no idea how this gets compiled at runtime. So if I create a new folder here called okay, so what's our main our main class is task, right? So we're going to create a task folder then. And then anything inherited by task goes in there. So leaf goes in task. Counter goes in task. And what was the other one we created? Definitely need to clean up. And that's it, right? What about branch? Was I supposed to... I don't need a branch yet. No, not yet. Right, okay. So I should have enough to actually have a go. So now I just want to work out how the heck I instantiate this. So let's do it in the game script. And on ready, let's create a new task. Yeah, so we're creating a counter task. Is it even possible to test this at this point? Is it all just structure? I'm going to have a look at this code repository and see what I've got. Oh, there we go.
Yes, you can test it.
Yeah? That's what I do, just create a new... you know what? I don't know if I've created any instances of anything apart from an object down here, right? .new, right? Okay, so var my task equals task.new. Is that it? So that's going to give me one of these. No, it ain't crashing. What have we got on my error bug?
Yes, make sure to add it as a child.
Oh, of course, to the tree. Yeah, okay. I've got a few errors I need to clear up, but nothing relating to this. So, right, okay, so again, I do that down here. Just look at the syntax. So it's not add to group. It is oh, add child. Yeah. Oh, right. Okay. Cool. So we'll just add this to our. Where are we? We're in game. So just can we do get tree and then get current scene. Oh, not button. My task. Right. I mean, obviously, it's not going to tell us. It's not going to do anything here at this point. No errors. No. Great. Okay. So we've got a task created. Now we want to start a counter. And oh, what's this? Tree show value. What on earth is that? Oh, tree inherited from? Yeah, it is. What's show value? What's that? Doesn't exist. Have we created a function for it? Nope. So that's not going to do anything until we actually implement it. Let's just have a look at this guy's code base.
You need to create an instance of counter and add as a child of the root task.
Right. Oh, wow. Cool. Okay. All right, let's try it. So, class counter couldn't be fully loaded. Script error or cyclic dependency. Is it? It's related to task, right? So, how the heck do we do that? Is it task.counter.new or something? I can't imagine that's right, but I'm going to try it. Didn't give me an error. I'm guessing that's totally wrong. I'm going to get.
Does counter have a class name?
Yeah, it does. It's called counter. Save myself a lot of headache if I just download this and have a look.
Just use the class name.
Yeah. Like that. Okay. Yeah, that's what I just tried. And I'm getting the class counter couldn't be fully loaded. Script error or cyclic dependency. Gonna try and get this. What's wrong with that?
This is a problem with class names, so just load .new.
Okay. Oh, really? Is it that it's like reserved or something? So, can I do this wonderful dragging? Oh, look at that. All right, super duper. And now we want to add that to the task as a child. That's genius. So actually, does that mean I can then, can I build up a behavior tree? No, I'm thinking like some sort of visual, because essentially we're constructing a tree programmatically, right? So, okay, so I want to get my task. So is it just get node? It's in scope, right? How do I identify it? My task? Wait a minute. Let me just have a quick peek. I want to see what's running here. So we go to remote. And game. There it is. At 22. How do I reference that?
You can do it visually if there is a scene for the script, but the example project you're using does not use scenes.
Cool. I like the challenge. I don't really want to. I don't want to use the scenes. So it's called at 22 in my scope here. My remote view of the scene
Hello.
tree. Hey, Abhishek, how you doing? welcome to the stream. Watch my pain as I struggle with this. 1-bit Godot, you might as well just take over the stream right now. I hope you do something on this. I'd be really fascinated to see, to watch your streaming. So, what I'm struggling with here is if we want to add this to, can we just reference it with get node and then just pass in my task? Is that going to work? Surely not. We'll just say var test equals, stick a breakpoint in there. All right.
My underscore task dot add underscore child, my underscore counter.
Oh, right. That easy. Okay, cool. Because see, I'm not looking at my task as a node. I thought only by adding, right, I see what you're saying. Okay, that makes sense. Right. Cool. All right, nice. Of course, now this is going to break, right? Because we don't have this method for displaying the count as part of tree. No. It's not crashing. Let's have a look at our remote. At 22, there it is. At 23.
How is a bot
counter.
helping you?
How is a bot helping me?
Create a function to show the value.
Yeah, I will. Yeah, that's it. A bot. Oh, 1-bit Godot. He's not a bot. He's a genius
really
programmer. No. 1-bit Godot is a Godot coder and soon to be streamer. So hopefully we'll get. Are you gonna stream on Twitch or YouTube? 1-bit. I'm guessing Twitch. But why not do both? Right. So we're gonna create a
Twitch.
My man. Nice. That means we can raid each other, right? So we can. I've never really done much on Twitch. I started on YouTube and I've just started on Twitch. But it looks like there's a lot of community functionality there. So let's up the ante and get some real Godot community coding going on. Okay, so I am going to add a method to print out my counter, which is in task, sorry. Now it's saying it's part of tree, so okay, I'm going to go into counter. Wonder why they've done it like that. Is that because I mean, why don't I just create a method in counter to show my value? And what is tree anyway? And how would I add a method to it if it's just a variable within task? Anyway, well, I feel like any method I should have for my counter should be in here. So I'm going to do a show counter here. And we'll just print it out, right? Print X. Pass in X. Too many arguments.
Just add the function to the same script you created the tasks.
Yeah. So, in task. Oh, right, in game. What, in the process loop? I just, you know what, I don't see why I would want to put it in there. I'm just going to see if that works first of all. No, it doesn't. Count 6 unique global class.
No, just add another function in the same script.
I am not with you. in the game script, like func, show counter.
Go back to he game script.
Yep, in there.
Yes.
All right. So now I've got to reference my counter, right? So I've got to print out my counter dot count. Identify my count isn't declared in the current scope. Of course, because I'm declaring it in ready. So just make these accessible. Is that all right? And now go into counter, scrap that. In fact, yeah, see, that's what I'm struggling with, right? Why would I want, because I'm calling it from task, right?
No, the actual counter is passed as a parameter to the function.
Yep, sorry, gotcha. Okay, so whatever it is, count. Okay, but isn't that going to be unaccessible at this point then? Because the task itself should be responsible for the action within this task, which is, I suppose, the point of having a task.
Assign self to the tree variable in the root task object.
Assign self to the tree variable in the root task object. So
my underscore task dot tree equals self.
Oh, okay, right. In the task object. Oh, I see. My task dot
no
tree.
Game.
Okay. My task tree equals self. Oh, I see. I'm with you. Right, so now I can put back the code in task then. No, sorry, in counter. So it was show counter, right? I'll just change it to show value. Blimey, man, my head just doesn't work this way. Show counter isn't clear in the current class. Where's show counter? Have I still got that in there?
The original function passes 2 parameters.
Yeah, sorry. Do I need that? I don't really care. There we go. Right. Oh, wait, do I have to do that? Final bracket. Good catch. Good catch. Right. Have we still got this error, or is that just old now? Let's just reset. Okay. Right. And no errors. Let's have a look at our function in the remote. And let's see our counter. Oop.
You need to still call run on the task.
Ah, of course, yeah. Cool. Nice. All right. So we can see our count at 0 there. So when we call run, oh, blimey. Exploded into errors. Let's just restart that. Okay. And remote. It's obviously not spitting out our count yet. Didn't give me an error though. My task.run. Oh, wait a minute. Do I need to actually run the counter function? Yeah. I need to run counter, right? Or do I? Or do I need to say, wow, I need to get my head around. Ooh. Non-existent functions show counter.
The root task should automatically run the child task.
Yeah, that's what I was thinking as well. So, of course, that did actually get to it there. Non-existent. I might just want to step through this, see what's going on. So, let's go into counter here. Are we even getting in there? Nope. So it's not running the child task yet, for some reason.
Run should be called in process.
Oh, of course, because we're running it every cycle. Right. Okay. Still not getting to our breakpoint in task. In counter. So run is still not getting
Show
called.
underscore value or show underscore counter.
Show underscore counter at the moment. So, oh, yeah. Either way, it's still not getting called, is it? I'm going to debug the task. I mean, sure, there's nothing wrong with that. It's probably just the way I'm initializing it, but I want to see. Oh, run doesn't do anything. Process the task and call running, but it doesn't. Start. Aha. Is it start? I think this code is incomplete. There's nothing there. And for some reason I can't get access to this repository, so I'll just download the zip. Tree master. Let's have a little look-see. See if there's anything in here.
Call start instead of run then.
Yeah? Alright, I'll give it a try. I'll just extract this anyway. Didn't look like start. Well, first of all, run didn't have any function in it. But start doesn't call run. It just calls...
I won't trust scripts from gdscript.com after that timer debacle.
Oh, I know. Yeah, so there's task. And if we hit start, it sets the status to fresh, and then for each child and get children, so it's going to find counter.
Start will run all the children task.
Yeah, and so when counter runs start, let's have a look at counter. Counter doesn't have a start. Counter's got run. And our leaf just has run, so it's never going to work. It's not going to call anything. Start's not going to do anything. I'll put it in anyway, just to validate that, but don't think anything's going to happen there. No. Right. Let's just have a quick look at. I think there may be a little bit of pseudo code to make it easier to read. Oops. opening up the same project again. Well, I've got you. Check it out. This is the first thing I did. I did parallax scrolling clouds. It's just basically a random cloud generator. But you can see the scene actually there. But it's got built-in... I was just messing with tweens essentially, and tweening between different colors. Playing with audio. Doesn't actually do anything. Anyway, nothing very exciting, except when the lightning strikes. Give me that lightning strike. It's coming. There we go. Hey. I love the engine. It's so cool. Right, anyway, let's have a look at this. So it's demos, import, browse, upper level. How do I go upper level? There. Demos. There it is. Right. So they have. He's giving you a sort of visual representation. Oh, jeez.
Okay, that task class is too abstract to work. You are right. The run function should not be empty. It should go through all the children and call run. I think you need to use another more specific type of task as the root.
Yeah, I think, I think I'm maybe diving in a little bit too deep too quick. I think I really need to understand the theory first, and then actually try and code my own scheduler or behavior tree. Or I'm not very comfortable going through trying to adapt something like this. I mean, this is a lot. If I struggle just instantiating a class, then I'm really going to struggle trying to utilize something like this. But I can see the benefits I'm going to get out of it, so quite keen to soldier on. So, okay, well, that's just test runner. So we can see we've got in his behavior tree, we've got task.gd, and hey, he's still got nothing in run. I wonder what this, well, presumably this does run and do something. Let's have a quick look. Right, there you go. Spits it out in a nice way. So how's he starting that off? So let's just test scene.
There should be another composite task class.
Composite task class. What makes you think that? How's he?
Use sequence as the root.
Let's see what he's doing. So he's got test, and then he's got test runner, which is this, which extends task. On ready, he is creating a link to his results list, adding a result. He's doing exactly what you said there, setting tree to self. Is that a standard sort of thing to do then? In your, I've just never seen this sort of thing before. Where, so that's task, and there's tree. I'm a little bit overwhelmed. Start. Okay, so he's starting already. So it automatically starts. The run is...
The scene can receive callbacks from tasks to process the results.
Yeah. So as soon as this is instantiated, it starts. So it's then going to loop through all the children, right? And kickstart. So we don't need the run. We didn't have this. There was no sort of starting point. I mean, this is so beyond me one bit. I need to do some more reading. I really need to actually read this. I mean, it makes sense. This all seems pretty straightforward. Okay, it starts off straightforward. Then it gets quite complicated. I think I just need to start an entirely new project, just playing around with this in order to achieve something like this. Certainly not going to happen quick. So, what time are you going to start streaming tomorrow? BST. What do you think? What's your... are you Asia Pacific time?
I can whip up a simpler example later. How can I contact you once I finished?
Blimey. You know what? I never thought of that before. Don't really want to put my email address on stream. Can I just message you on Twitch? I think I can, right? Let's find you on Twitch. 1bit Godot.
Oh, there you go. Please, sir.
Yeah. And follow. And then, yeah, I think, add friends. That'd be awesome, man. There you go. I've friended you, so you can add me on there, and I'll ping you. There you go. That's my email address. Awesome. Well, you know, it's 10:15 now. I'm trying to do it. I don't want to go too long and too fast, so I'm probably going to stop at this point. I haven't got very far with what I intended to do, but wow, I've learned quite a few things. Key things that I've picked up on here are... Let's go back to the project. Well, I mean, majorly, the instantiation of classes and using, classes as they're meant to be, as opposed to scenes and scripts. I'm a bit more used to using JavaScript and coding like this. So where is it? Task. Yeah. In fact, actually, I'm going to load up game. So, I think, when I was adding children to the tree before, I don't think I really gathered exactly what I was doing there. So that's awesome. Being able to do this, being able to load a script and instantiate it as a class, awesome, amazing. And this concept, assigning a variable inside the task and then assigning it to the node that you're calling or instantiating the class from. That's very cool. That's something I'm not used to. And that seems to open a lot of possibilities of where you put your code. And it frees your task, your behavior tree to connect to any given object within your game. Very handy. I worry that when it comes down to it, I'm not going to be able to introduce those concepts as I go, but we shall see. So, 1-Bit Godot, thank you so much. Honestly, really enjoyed having your guiding hand there. It's taught me a lot. This is not about teaching other people. Well, my stream isn't. It's about teaching me at the end of the day. So thank you very much for helping out, and look forward to chatting to you on Twitch later on. Thanks everyone for watching, and I'm going to call it a night. It's not as late as it is for 1-Bit Godot, but it's still coming up to beddy buys for me. So thanks for tuning in. I'll be back tomorrow, 9 p.m. BST, and don't forget to look out for 1-Bit Godot's stream. Why not tune in around 6 p.m. BST and see if you can catch him. If I see him on stream, I will be announcing it, and I will be following and what's the word on Twitch? Hosting his channel. So if you're watching mine, you'll see his. Either way, thanks again and have a good night. Cheers, 1-Bit Godot. Cheers, anyone else that's watching, and catch you tomorrow.